Good afternoon, grade 12s. This afternoon we are doing elimination reactions. Okay, so yesterday we did addition reactions, and today we're going to do elimination reactions. According to our planning, it is in the textbook page 113 to 115, and afterwards you're going to do the elimination homework, which has 1 to 7 questions. Okay, there is the homework for the addition reactions. Question 1 to 5, I already sent it on your groups. Okay, then we start with elimination reaction. Elimination reaction is a reaction in which atoms or groups of atoms removed from the adjacent carbon atoms in a saturated organic molecule. So in other words, we are going to take a saturated molecule and we're going to break it into two molecules. So this is actually the opposite of what we have done yesterday. So we're taking our saturated molecule and we are taking out the Y component, in this case here, and the Z component, in this case here. The Y and the Z will react and they will form our new compound, and again these bonds are now making a double carbon bond. Our first elimination reaction, Dehydrogenation. So we're going to take out a hydrogen and we're going to take out a halogen. Okay, in this reaction we are eliminating a halogen and a hydrogen. The reaction conditions must be dissolved in ethanol. The concentrated solution of a strong base. Please be very careful here. There is a similar reaction in substitution. So it's a strong base which we will have here, and it will be dissolved in ethanol. So normally it is a hot ethanolic reaction. Strong heated with reflux, the vapor condenses and it returns to the reaction flask during heating. So we will have a haloalkane and a concentrated strong base, and the products will then be an alkene, a salt and water. So we will get 3 components here from this reaction. So there you can see, here we have a hydrogen, there is a hydrogen, there is a iodine. So these two are now going to react. Okay, so what's going to happen? They are going to form a reaction. I'm incorrect. Okay, sorry. The potassium and the iodine will react, and the OH and the hydrogen will react. So what will happen is, with the help of this strong base, we will get an ionic compound, which is our salt, and then we will get our water, which forms. Like you can see here, there is our reaction conditions again. Here, the reaction conditions is very important. Okay, let's look at this one where we just have hydrogen. Alright, so here we just add heat. It's also dehydrogenation. What will happen is, we are actually just taking out one hydrogen there, also one chlorine, and then these two will react to form our new ionic compound. But this is not in the presence of a strong base. Okay, now something which we must talk about is, previously we talked about Markovnikov's rule. Now when we have an elimination reaction, we actually following Zaitsev's rule. Now Zaitsev says the following. They say the hydrogen atom is removed from the more substituted carbon atom, and the carbon that is bonded to the most number of carbon atoms. So in other words, if we need to look at the bond here, we can make a bond between hydrogen and bromine. That's the two that can be eliminated on the left, on the blue side, or on the red side we can take hydrogen and bromine. So if we follow Zaitsev's rule, then this is the hydrogen we are going to actually use. because we will form the major compound from there. But like with Markovnikov's rule, there is also a minor compound. So the blue compound will actually form, but in minority. And then obviously the Br and the Na will form our ionic compound, plus the OH and the H will form our water. That is then dehydrogenation. Okay, now we're going over to dehydration. So that's what the word says. We are taking water from our compound. So dehydration reaction is where water is removed and the hydrogen forms a reaction with the OH group. So what do we need? We need an alcohol, we need a concentrated H2SO4, and it forms an alkene and water. Reaction conditions, we need a very strong catalyst, namely sulfuric acid and phosphoric acid. The acid is then the dehydrating catalyst, remember, like in esters, where it dehydrated the reaction, and then we will form the alkene and the water. Okay, so there we have our ethanol. So we have our OH, which will be removed, and our H. They will form water, and we will have then our alkene forming. Very important, this must be in excess, the catalyst, otherwise the reaction will not be removed. Obviously, if we have a bigger compound again, Zaitsev's rule is also going to be applied here. So you look at the red one and you look at the blue one. The red one is the major compound, that is according to Zaitsev. So we will remove the hydrogen from the least substituted carbon, or the most substituted carbon atom where there's hydrogens, and the OH, and then we will find our double bond. Right, now we are at number 3. Cracking of hydrocarbons. This is actually an application process as well. Cracking is the process by which longer chain hydrocarbon molecules are broken down into shorter and more useful molecules. So we will get thermal cracking and catalytic cracking. Thermal cracking is the cracking of hydrocarbons under high pressure and high temperature. Reaction conditions: high temperature, high pressure, reactants will be alkanes. Catalytic cracking is the cracking of hydrocompounds under conditions of low pressure and low temperature with the help of a catalyst. Lower temperatures, lower than 800, low pressure, and a catalyst. Reactants is alkanes, and we form alkenes and alkynes, or alkenes and hydrogens. Okay, how do we predict what will form? An alkane will form a shorter chain with an alkane and an alkene length, and one or more alkenes and hydrogens can be formed if we have higher energy. And we're looking at ethene, which will then break out, ethane, that will then break up into ethene and water, so it's actually elimination of H2. Then we have butane. The butane, we will break it into 2 pieces, namely a propene and a methane. Products formed by breaking a CH bond. Here again, you will see we can form a butene and a hydrogen, or I can take the compound and break it into 2 ethenes and hydrogens. What is the importance of cracking? For petrol, okay, we use it for gasoline and petrol at filling stations. Remember, tonight the petrol will also go down, so tell your parents to go and fill up. The alkenes, the crude oil is underreactive, and then the hydrogens is used in the ammonia process. Thank you very much. Your homework is exercise 12 of elimination, question 1 to 7. See you guys